Well, good evening, everybody. I'm Derrick Pitts, Chief Astronomer at the Franklin Institute Science Museum, your cool astronomer, with the June 2023 edition of Night Skies at Home. Night Skies at Home is your home astronomy program from the Franklin Institute that helps you find your way around the evening skies. And now that we're almost at summer, this is the perfect time to have this kind of information right at your fingertips so that you can have a lovely evening outside under the night sky with some knowledge about what's going on up there. So, tonight for our program, our topic tonight is the summer solstice and seasons on other planets. Can you believe other planets have seasons? Yes, indeed, they do. And we're going to talk about those seasonal program, or we're going to talk about those seasons on other planets just as soon as we get our program started. Right now, we're just going to introduce the show so that people have an opportunity to join with us as the program gets started. We're so glad you could be with us. Welcome to the program, and let us know where you're listening to the program from. We'd greatly appreciate that. And also, we'd love to hear your astronomy questions as well. So, if you have any questions about anything I speak about this evening or anything related to astronomy, we'll be happy to take care of that too. So, please let us know. Our topic again tonight is the summer solstice and seasons on other planets. Again, this is the June 2023 edition of the Franklin Institute's home astronomy program, Night Skies at Home. For this program, you don't need to be an astronomer. You don't need to know a lot about astronomy. In fact, it's very much like an introductory program to astronomy, although we've been doing this for quite some time. Can you believe this is episode number 46? Right, so we've talked a lot about astronomy. In fact, I'm coming to you live from the American Astronomical Society conference, and I have been hobnobbing with astronomers from around the country, talking about what's going on in astronomy these days, as well as discoveries and instruments that are being used and designed and things like that. So it's all very, very exciting. But for this evening tonight, we're going to talk about what's available in the sky where you're observing from. So let us know where you're observing so we can help you see what's there and know what's there. I had some interesting questions from folks during the week about things they saw in the evening sky, and I thought I'd cover that too, so that just in case you were having some questions about what's out there in the sky, you could have a way to know what's going on out there. So, again, this is the Franklin Institute's Night Skies at Home astronomy program, number 46 for June 2023. I'm Derrick Pitts, Chief Astronomer at the Franklin Institute, your cool astronomer here to help you learn your way around the night skies. So, as we get started with our program this evening, oh, look, I see we have Smokey from Montgomery Town. Oh, hello from Smoky, Montgomery Township. Ah, I see. We have Deborah from Huntington Valley. I see Doug is in Pottstown. Hi, Doug. Thanks for joining us tonight. Let's see, Jennifer from Media. Hi, Jennifer. Thank you. We have Tom, and is that Tom? No, Terry in South Jersey. Not seeing anything due to clouds and smoke. Thanks for that, Terry. I've heard that the sky is really smoky there right now because of the wildfires up in Canada. So hopefully that will clear out soon and we'll be able to go back to seeing the evening sky. Which brings me to a point about what we'll talk about. The objects that we speak about that are available in the evening sky tonight, they really will be available for about 3 weeks. So you don't have to worry about missing something just because you can't see the sky tonight. I like to provide enough information so that whenever it's convenient for you to get outside to observe, you'll be able to see what's there. Now, if you can see the view behind me, I'm not going to claim this is something that you're going to be able to see even from Warminster, where Gina is. Now, you won't be able to see this. This is the Eagle Nebula, as is taken by the James Webb Space Telescope, with special filtering done and contrast enhancements so that scientists can see all the details of the structure of the nebula. This is all cosmic gas and dust, places where stars are being formed. And in fact, right at the very tippy top, right here at the end of this finger, right there, you can see some glow. And in that column of gas and dust, there's a very young hot star that is glowing right there. And in fact, the radiation from that star is so intense, it's beginning to eat up the gases in that column. And so in a few 100,000 years, all this column will be gone because all of the gas will be eaten up. So Cool things to see in the sky here through James Webb Space Telescope. Cool things to see in the sky as you're observing. So, first things first, let me go back and just say, let us know where you're observing from. What can you see of the sky from where you are? I know it's kind of smoky in some places, but for other folks around the country, it might be clear. We'd like to find out where you're observing from. Thanks. Let us know. And we'll also take your astronomy questions. We see some questions here, and we'll make sure that we get to your questions. I'm observing the sky tonight from New Mexico. I'm in Albuquerque at a conference, and the sky out here right now is actually pretty nice. It's not dark here yet, of course. It's just 2 hours earlier. It's only just about 6 o'clock, here. So the sky is still quite bright. So I'll have to wait for a little while for it to get darker, but it's kind of clear out here. Okay, great. So let's just see. Let's do some sky phenomenon so we understand what's happening with the sky right now. Here we are. It's June the 8th, and this is what we can think of as certainly late spring because we're just a few days away from the summer solstice. The first day of summer comes up soon. And because of that, that means we're right at the peak of the amount of sunlight or amount of daylight we're going to have for the entire year. This is the time of year when we have the greatest amount of time of sunlight. So sunrise right now is happening at 5:31 a.m. 5:31 a.m. and sunset is at 8:28 p.m. Now we still have a few more minutes of sunset to gain, and then once that's done in another week or two, that's going to be the end of it. Now, let me go back to the front end of the day, the sunrise portion of the day. I said that sunrise, and this is for tomorrow, by the way, for Friday. Sunrise is at 5:31 a.m., 5:31. Well, it was at 5:31 this morning. And if we look at the sunrise times across this period of time right now, about 7 to 10 days right about now, we'll see that the sunrise time is pretty stable right now. In fact, we're only gaining about 44 seconds of time a day right now, almost a minute a day. But for the sunrise, it's now stuck right around there. That means that we won't have the sun rising any earlier. So we've finished adding time to the beginning of the day. We can only still add time to the end of the day. Well, as we get to the summer solstice, that's a very special period because that's when all of the time gaining stops. We'll be at that time of year when we have the greatest number of hours and minutes of daylight for the year. And this is the time when we should really be outside enjoying it all because we're going to start to lose that time in just a few weeks. We'll get to that when we talk about summer solstice. Let's continue. What else is happening right now? The moon is a waning gibbous moon, And in fact, it rises very early tomorrow morning. Well, really very late tonight, 12:54 a.m., just 6 minutes before 1 a.m. That's when the moon rises as a waning gibbous phase moon. Now, this means, waning gibbous, that it's after the full moon phase. And as it continues in its orbit around the Earth, we're starting to see less and less of the illuminated surface. So it's not down to a waning crescent yet. So it's halfway between full moon and last quarter. Last quarter is when we see that half moon very, very late at night or in the morning sky. Actually, we can do it that way too. So that's what this phase is, the waning gibbous moon. Again, it rises at 12:54 a.m. and it sets tomorrow at 11:25 a.m. 11:25. I have my notes right over here, which is why you see me going like this, just to make sure I get the numbers right. So thanks for bearing with me. The new moon comes up on June 18th. June 18th is the next new moon. Keep track of that new moon because, as it turns out, it's going to be instrumental in helping you find certain planets a little bit later this month. And I think you'll really enjoy keeping track of the moon as it makes its way past these planets. So keep that in mind. Okay, let's see. Thank you very much for your questions. We're going to get to them. I see one here that's really involved. Mike is asking, what holds cosmic gases in place? There's a really simple answer for that, Mike, and I'm going to ask you to demonstrate it on your own. Just take something with some mass. I usually use a set of keys or something like that. Make sure it's something that isn't fragile. Hold it up above the floor and then let it go. You need to use something unbreakable. Well, when you let that object go, what's the force that pulls that object to the floor? Bingo. There's your answer. Okay, great. Universal, it's everywhere. It does more than just hold us on this planet. It does a tremendous amount around the universe. In fact, it's ubiquitous. Everywhere that force is driving what's happening out in the universe. Okay, so we have great summer constellations coming up also that are out there. And as I said, the summer solstice comes up on June 21st. Comes up on June 21st. So there's plenty of stuff to see in the evening sky. Let's talk about what's out there in the evening sky, by the way. Sure, let's see. Well, over on the western side of the sky, after sunset, as the sky is darkening, you'll be able to see two planets, Venus and Mars. We talked about Venus and Mars being visible last month. They're also visible this month, and they'll continue to be visible for another 3 or 4 weeks. And then things are going to start to change in the western sky. But right now, you can still identify them. Venus is tremendously easy to identify because it's the very bright white object over on the western side after sunset, about halfway up the sky. In fact, it's the brightest object in the western sky all evening. You can't miss it, and it's hard to mistake it for anything else. You might think it's the moon because it's so bright, but it actually isn't. It's the planet Venus reflecting light from the sun. Now, not far from Venus as we see it in the evening sky stands our other neighbor planet, Mars. But let's be careful not to confuse what those positions are like. Venus is the next closest planet to the sun, our neighbor planet going in toward the sun, and Mars is our neighbor planet out on the other side, going outward from the sun. So the Earth's orbit is actually placed between these two planets. So as you see the two in the evening sky, Mars, by the way, is nowhere near as bright as Venus. It's a little reddish in color, pinkish actually. You won't see the color until the sky actually gets a bit darker. So you have to wait for that to happen. And it's just above Venus. So if you look into the sky, you'll see where Venus is. Look just above Venus, and you'll be able to spy an object that's sort of rosy in color, doesn't have any twinkle. That'll be Mars. Well, think about it. There's an enormous, enormous gulf of distance between Venus and Mars, enough to fit the orbit of planet Earth in between them. So it's tens of millions of miles. In fact, it's probably more than 100 million miles between those two without much difficulty at all, in fact. So there's an enormous gulf between them. So don't be fooled by how they look like they're close together in the sky. They There we go. I hope we're back. Okay. We may be having some network issues, but we'll see how that works out. Let's move forward anyway. In any case, welcome back. I'm back. Hopefully that's worked out okay. Also in the pre-dawn sky now, way over on the eastern side, very early in the morning, 3:30 or so in the morning, Saturn is now making its way above the eastern horizon. Thank you, Doug. I appreciate that. Yeah, I was just saying that Saturn is now making its way above the eastern horizon very early in the morning, say 3:30 or so. And if you wait just another few weeks, Jupiter is also going to begin to make its way up in the pre-dawn Ah, yes. I see we're having some streaming difficulties coming live from New Mexico. Hope you're still with me. My technical director, Katie, is doing the best she can to keep the stream going. And Katie, what I'd like to try to do, if we can right now, is uh, let's take a trip over to Stellarium Web Online, if you can. Let's see if we can. Let's see if we can do that. Let's see if we can do that. Katie will try to set that up for us. And while Katie is trying to set that up for us, what we're going to do is we're just going to talk about a little bit of the difference between what you can see in different places. So if you're viewing this program from much further north, well, then what's going to happen for you is the sky that you're going to miss seeing is on the southern horizon. So you'll lose southern horizon sky. If you happen to be in the southern portion of the viewing area, say down in Florida or say Louisiana or something like that, you're going to lose some of the northern sky, but you are not going to lose anything valuable at all. Okay. So I see Katie has brought our sky view up. This is Stellarium, the web version, which I really like to use. And this is a really wonderful tool to help you find your way around the evening sky. It's online, very easy to get to. Stellarium web.org, I think. So I'm just going to check in and see. There we go. Okay. I'm still here. Great. Wonderful. It's always a challenge when you're trying to do things live on the road. Please bear with us. We hope this will work out. We were just talking about what's available to be seen in the sky. We were going to use stellariumweb.org as our tool to get us around the sky. And hopefully, Katie will come back and bring that back for us. But here's what's available for you to see in the evening sky. It's really easy for us to talk about this. There are these fabulous, great star patterns that are out there. Thanks, Mike. Glad to see you're still there. Thanks for holding on with us. Okay, great. Okay, so I see. Okay, here we are. All right, I'm just adjusting my time, folks, on Stellarium so I can see where we are. Okay, so outside under the evening sky on a night like tonight, right around 9 p.m., because the sky is just beginning to get dark, we're going to start over on the western side of the sky. So if you'll just follow along with me, maybe we can get through this okay. So, right around 9 p.m., as you're looking out toward the west, you'll be able to see Venus placed halfway up the sky without too much difficulty at all. It's actually quite easy to see there, as I said before. And Mars, if you think of it as you're looking right out toward the west, Mars is kind of at the 10 o'clock position, if you will. If you were to see Venus as sitting at the center on the face of an analog clock, well, where the number 10 where that is. Right up there. We can see that without too much difficulty at all. Okay. But what we're going to do is we're going to come right around to the southern portion of the sky. And as we come around to the southern portion of the sky, we'll make things a little bit darker. We'll go just a little bit later, right around to 9:30, where the sky has gotten quite a bit darker. Now, with the sky around where it is here, what this does for us is this now allows us to see where the main constellations of the summer sky are. Well, almost directly overhead in the south is the constellation Virgo. The stars are not so bright, but still higher in the sky is a lovely orange star. And that orange star is called Arcturus. It's the brightest star of the constellation Boötes, the herdsman. And this is now really leading us into summer because as we come down below those, we find the sprawling constellation of Scorpius right down on the horizon, a little bit over to the eastern portion of the sky. But this is really the beginning of the edge of our Milky Way galaxy. And the Milky Way galaxy is going to stretch up from the southeastern horizon in an arc up along an angle headed up toward the north. And if you're someplace where the sky is dark, you'll be able to see the combined light of the billions of stars that make up the Milky Way galaxy, and you'd be able to see where that sort of path of fuzzy bright light is across the sky there. So as I'm describing the sky to you, what Katie has done is Katie's put the link for stellarium-web.org so that you can all reach out to it and see it without much difficulty. And Katie, I'll ask you if you can give that a shot again and see if we can bring that back up, and we'll try to crash along from there. So the main features of the summer sky that you're looking for really all revolve around the Milky Way. Now, even if you can't see the Milky Way, that's okay, because there are easy lampposts, guides in the sky, in the constellations that you can use to find this. Very simple. So here's how we're going to do it. You'll start out facing the south. And at 9:30 p.m., facing the south, just a little bit to the left of south, is where you'll see the Scorpion constellation, where you'll see Scorpius right there. Now, Scorpius is right next door to another constellation called Sagittarius. So, of course, the Scorpion looks like a gigantic S-shaped constellation, a sprawling S that falls right down onto the horizon. And you can see that without too much difficulty because the stars are quite bright. Now, to the left of the Scorpion is the constellation Sagittarius. It looks much more like a more common household item feature than what its mythological representation is supposed to be. Well, the common household feature is a teapot. The bright stars of Sagittarius make a teapot shape. Now, really, Sagittarius is supposed to be a centaur with a bow and arrow. Half man, half horse, with a bow and arrow. And of course, he's shooting the bow and arrow across the Milky Way from left to right, sort of in the direction of the Scorpion. Of course, the arrow never leaves the bow, so the Scorpion isn't really in any danger. Well, these two sort of mark the anchor points for the Milky Way, the edge of our galaxy as we see it in the sky, this soft combined light that sort of makes a fuzzy white cloud that stretches up along the sky. Well, if we start with those two, we can follow an arc up through the sky until we come to three bright stars that are almost directly overhead. These three bright stars are the brightest stars of three constellations. We're talking about the constellation Cygnus, the constellation Aquila the Eagle, and the constellation Lyra the Harp. Lyra's bright star is called Vega and is the brightest one of the three as you look at them. The other two, Deneb, which is the brightest star of the constellation Cygnus, stands off at an angle a little bit more toward the north. And then the constellation Aquila the Eagle's bright star stands a little bit down to the south. Well, if you put these three stars together with three lines, you come up with the geometric shape of a triangle. So this is now the summer triangle. and its three stars right ahead now, perhaps a little bit to the east. And now you've been able to find some of the main constellations of the summer sky. Get better, of course, as the summer goes on because they will move into a better position for viewing. They'll come right into the center portion of the sky by the time we get to early July. And that way, you'll be able to start right at the southern horizon, come right up the sky, right up to the summer triangle, where you'll be able to see the three bright stars that identify these three constellations. So that won't be too difficult. Now, of course, what you can also do is you can use these same groups of stars to find your way along to the Big Dipper. Now, of course, the Big Dipper is one of those constellations that almost everyone knows. Most people know it's around in the northern portion of the sky somewhere, and you have a good idea of what the shape looks like. But maybe you're a little bit confused about how to find it. Well, here's a really easy way to do this. Just a few minutes ago, we spoke about the bright star Regulus. That's part of the constellation Leo the Lion. That's just above where Mars is over on the western side of the sky. Well, if you go over to where Regulus is and just come straight up the sky from there, well, you'll come to the Big Dipper because the Big Dipper actually hangs out right above Leo the Lion. So if you can find Regulus from Mars, take a line right up toward the top of the sky, you'll come to the Big Dipper. Very easy to locate. So now you have three sections of the sky you're observing. You're observing the southern sky, the overhead sky, and the western sky, all at once to find these very familiar constellations. Constellations that are much further over in the east, we'll talk about a little bit later as they come up to a better position in the sky. But this is enough to get started with right now. So that's a good thing to take a look for. Those are three good things you can take a look for to start from there. Now, something you might also consider doing, now that we're talking about summer and being outside at night and enjoying the warmth, take an opportunity to get to some place where the sky is clear and dark. Last month, we talked about great places to go view around the Delaware Valley, places where the sky was a lot darker, where you might get a better view. Well, now's the time to take advantage of one of those locations, of course, being aware of safety and all those other sorts of things, so that you can get a look at what the Milky Way looks like. Now, if you're right in an urban area, right under bright lights, if you're in Philadelphia or if you're in any of the other places that you've written in that you're viewing from and you're working right where there are plenty of lights, it's going to be a real challenge to see the Milky Way. So get yourself out away from those lights. And here's a really great tip. Go to a place where the sky is dark, but take a pair of binoculars with you. This way, you can have some optical aid that you can use to scan along the Milky Way. You'll be amazed at what you can see. And in fact, this is a really great way to start observing the sky under magnification. Now, I suppose you could look at the Milky Way with a telescope, but then you'd have a tremendous amount of magnification looking at a very small portion of the sky. And the Milky Way actually looks best under low magnification as you look at a broader swath of the sky. So I recommend binoculars for observing the Milky Way, along with using binoculars to observe planets. Here's a really interesting thing you can do with binoculars observing planets. Of course, you'll want to look at Mars so that you can enhance the color of Mars. But take a look at Venus. What you might be able to notice about Venus is that if you look at it under magnification, it actually looks like a crescent rather than a full disk. Yes, it can look as if it has phases like the moon has phases. But I'll leave that for you to discover. And if you remember our discussions about how the moon has phases, just apply that to what you're seeing of Venus and think about how it could be possible for Venus to have phases. Think about it. It all goes together really nicely. Okay, well, let's get on to our topic of the evening, the topic of the month, seasons on other planets. Seasons on other planets. Did you ever imagine there could be seasons on other planets? Well, as it turns out, yes, it is possible for there to be seasons on other planets. But let's first start with seasons right here on our own planet. how is it that we do have seasons on Earth anyway? Well, it's all tied to two basic factors about the Earth and its relationship to the sun. And it goes like this. The Earth has a rotational axis. You've all seen this on a globe or in a picture. Somewhere you've seen that the Earth has a rotational axis. This is the imaginary line that goes right through the center of the Earth from the South Pole all the way up through the North Pole. And the Earth rotates around this rotational axis. Well, if we think about the positioning of that rotational axis, it's not perfectly vertical. In fact, as it turns out, the Earth's rotational axis is tilted 23.5 degrees away from vertical. So that's point number one that allows us to have seasons is the angular tilt of the Earth's rotational axis. Number two, the Earth orbits the sun once a year. If we put those two factors together, that allows a planet to have seasons. So every planet in our solar system that has a tilted rotational axis and orbits the sun will have seasons. Now, they won't be seasons just like we have here on Earth. Let's clear that up right now. So much has to do with the atmosphere. It really makes a huge difference, of course. And as well as proximity to the sun makes a huge difference. But those two basic factors are the ones that will determine if a planet has seasons. So a planet might have really long seasons, or it might have really short seasons, or the seasonal variation might not be very much. We'll find out in just a moment. But here on Earth, this is what makes it possible for life to develop here on Earth. The fact that we're at the right location away from our star, and that tilt and the rotation around the sun, or the orbit around the sun, gives us that. So let's take a look first at the planets of our solar system and see what these planets of our solar system have that make it possible for them to have seasons. Well, let's see. Let's start first with let's start first with Mercury. First planet of the solar system, one closest to the sun. Mercury isn't, I wouldn't say odd, but it's in the wrong position. It's not in a good position. First of all, it only takes Mercury 88 days to orbit the sun once. So it has a very, very fast orbit around the sun. But you know what? It has no axial tilt. So without any axial tilt, it can't have seasons. It does have an atmosphere, but it's a very, very thin atmosphere called almost what you'd call an exosphere. And this exosphere is typically the very last layer of atmosphere for a planet before the atmosphere transitions over to space. So Mercury, as small as it is, only has an exosphere for an atmosphere. It orbits the sun in 88 days, and it has no axial tilt. So I wouldn't say Mercury is the place to go if you'd like to experience seasons. However, we could go to Venus. That's a place that we might try. It takes Venus about 167 days to orbit the sun once, in Earth days, that is. And you know something? It has only a 3-degree tilt, not very much at all. But it has something else that's really odd about it. First of all, it rotates on its axis very slowly, very slowly. In fact, if you were to measure how long it takes Venus to rotate on its axis and compare that to Earth, on Earth, it takes us 24 hours to rotate once. On Mars, wow, it rotates 3 times in 2 of its years. It rotates only 3 times in 2 of its years. So that means that it has a really odd ratio of rotation to orbiting around the sun. And that odd rotation makes things very, very weird on the planet. And here's the weird thing about it. Did you know that Venus actually rotates backwards? It rotates backwards. What's forward and what's backwards? Well, forwards for a planet is a planet that rotates on its axis from sorry about that, that rotates on its axis from west to east. And as it rotates on its axis from west to east, that makes it seem as if on Earth the sun is rising in the east and passing in the west. So, as we're standing outside during the day, if we're out at noon and we see the sun high in the sky, we know that 2 hours later the sun is going to be a little bit further to the west. That's not because the sun has moved, it's because the Earth has rotated on its axis. Right. So on Venus, it goes the other way. It rotates instead of west to east, from east to west. Now, all these little things combined make the sun have a very odd path across the sky occasionally. Well, that odd path even involves the sun appearing to rise, making its way slowly across the sky. Remember, it only goes around 3 times for every 2 times it orbits the sun. So that means the days on Venus are really, really, really long, very, very long. But the sun will appear to come up in the sky, stop in position, move backwards, and then resume its forward motion. That's very, very strange for a planet to do something like that. So let's come back to Earth. Here we are on Earth where we're very familiar with the seasons. It takes the Earth 1 year to orbit the sun, about 365 days. And in that 365 days, the year is divided up almost evenly, such that there are about 90 days per season: spring, summer, fall, and winter. They're just about equal length. Not exactly, but just about equal length. Well, that's the way Earth is. But Earth, again, has this 23.5-degree tilt. And so if we start to look at other planets, we find that Mars is very much like Earth because it also has a tilt that's very similar to Earth. It's a little longer of a tilt. It's a little greater of a tilt than Earth is. So we're at 23.5 degrees, and Mars's tilt is a few degrees more, just enough that the seasons are a little bit different here. So the other thing that makes a big difference is that Mars's orbit is 2 Earth years long. And for 2 Earth years, with that tilt, it means that the seasons last about 6 months. Not quite altogether equally 6 months. It goes like this. Spring and fall on Mars last 171 days. 171 days. That's almost 6 months. The Northern Hemisphere summer lasts a little longer at 199 days, and the Northern Hemisphere winter runs about 146 days. But that's all due to this large variation in the distance of Mars from the sun, from its closest approach to the sun, to its most distant orbit away from the sun. Let's go to Jupiter, the gas giant of the solar system. It has a 3-degree tilt, and there isn't really very much of a seasonal difference, but there is a slow change due to the solar orbit, how long it takes Jupiter to orbit around the sun. It takes about 12 years. And in that 12 years of going around the sun, there is a difference in heating and cooling at Jupiter, although it doesn't really amount to very much, because let's not forget, the temperatures out at the upper cloud tops of Jupiter are a few hundred degrees below zero to begin with. Now, Jupiter is an odd planet. It heats up as you go further in. And in fact, if you go in toward the center of Jupiter, the center of Jupiter gets to be almost as hot as the surface of the sun. So that's a very complicating factor. And because of the differences in temperatures, there are tremendous storms in the atmosphere of Jupiter. But that's not really a seasonal thing. That's just the internal dynamics of the planet. We're just talking about seasons here. So let's try Saturn. Saturn has a 27-degree tilt, and its seasons last 7 years. Here again, we're just 3 months on this planet, but out at Saturn, 7 years. It has a 29-year orbit, and that's what also complicates it. But if we go further out, let's go out to Uranus. Uranus is really odd. Why? Because Uranus's rotational axis is tilted 98 degrees away from vertical. 98 degrees. That makes a huge difference. It has an 84-year orbit, and this means that seasons last 21 years. 21 years for one season. Now, at that distance again, It's a very cold, extremely cold that far out. But again, it does warm up slightly when, as it orbits the sun, it comes just slightly closer to the sun because of that difference between the close approach of the planet and the more distant pass around the sun. And that can cause superstorms in the frozen atmosphere of Uranus. Now, let's remember that the temperature in the atmosphere is easily 300 degrees below zero. So, when we talk about superstorms, we're not really talking about hurricanes like we see here or tornadoes like we see here, but a tremendous amount of turbulence in the atmosphere. Next, of course, is Neptune. It has a 28.5-degree tilt. It has a 124-year orbit approximately. It has seasons that last 40 years. 40 years. And there's hardly any variation seasonally. But this brings me to Pluto. I just wanted to add Pluto because of this really interesting fact about Pluto. It has a 120-degree tilt away from vertical, a 249-year orbit, but believe it or not, it snows at Pluto. Now I'm sure you're saying, wait a minute, how can it possibly snow? Is there water in the atmosphere? No, not at all. It's actually a very weird process in which the very, very slight gaseous atmosphere of Pluto can do what's called sublimate, which means it converts from a solid to a gas, and then it can go from being a gas to being a precipitate. Now, let's think of the snow cycle here on Earth. We know how snow falls from the sky because it's frozen rain. The atmosphere is very cold. The snowflakes, snow crystals form in the atmosphere and the clouds, and then they fall out of the clouds and come down to Earth. Well, think of the gaseous atmosphere of Pluto being able to do the same thing. Falls down to the surface when the temperature gets cold enough. But what kind of cycle are we talking about here? 248 years, 249 years to orbit the Earth once? Well, that means for half of its orbit, let's just say it's 248 years let's say it's 250 years for easy division. For 125 years of Pluto's orbit, it's slightly closer to the sun. So the atmosphere of Pluto is just slightly warmer than usual. Well, that slight warmth seems to be enough to cause the frozen gas at the surface to do what's called sublimate, and that is to convert directly from a solid into a gas and become this atmosphere. Well, it may hang out there for 125 years until the planet gets around to its more distant orbit from the sun when the atmosphere cools again, and this gas can then condense, precipitate, and fall out as snow. That's amazing. Hard to believe that there could be snow at Pluto. But as long as there's an axial tilt and it orbits around the sun, there can be seasons. Wildly different from what we have here on Earth, but they certainly can have seasons. So as we continue to explore the rest of the galaxy and we identify other planets orbiting other stars, we may come to learn that those planets have seasons as well. Some of the interesting things about our sun, about our solar system, as a place where all sorts of great things are happening. Okay, so I was just going to check and see if we had any questions from anybody. If you're still with us, which I hope you are, we'll just check and see if there are any questions here. I see, Alan. Alan has written in, and he says, greetings from Doylestown. We're on Saturday night of the Memorial Day weekend at 9:28 p.m. He saw a bolide meteor that lasted for nearly 4 seconds. That's great, Alan. Thanks for letting us know about that. Maybe somebody else saw that on the Saturday night of the Memorial Day weekend at about 9:30 p.m. A bright meteor streaking through the sky that lasted for about 4 seconds. If anybody saw that and was traveling from south to north in the western sky, let us know. Thanks a lot for that, Alan. We really appreciate. Mike is asking, how would we age on Venus? I think you'd age the same way on Venus that you age here on Earth. I'm now thinking, while you might age the same, it would be a very different experience, of course, because the atmosphere of Venus is so caustic and so hot. What do I mean? Well, the surface temperature on Venus is 800 degrees Fahrenheit, not a very comfortable place to be. I would suggest that maybe your life would not last very long on Venus. So the only thing that would be different, Mike, in terms of the number of years is that you just count the years differently. So rather than count them the way we do it, you'd have to count it according to Venusian years, about 167 days per year. And that way you'd run up more years faster than you would here on Earth. So there's that. Thanks a lot for that. Greatly appreciate it, Mike. Doug asks, I've heard about SpaceX satellites marching across the sky in series. Is this true? Yes, you know what? Actually, Doug, this is correct. The satellites that SpaceX has been putting into orbit as part of the Starlink internet communication system actually are arranged in very, very long lines of satellites called trains. They're called trains. So you can think of them just like trains with a locomotive at one end and a caboose at the other end and some cars in between. Think of them like a string of cars going across the sky. When they are first launched, each of the satellites in the train of satellites happen to be quite close to each other, so you can see them following one after another. But as they begin to reach their orbital positions, that line stretches out. And so you don't see them as close together anymore because they stretch out to form what's called a constellation. Yes, that's what they're called. They're called constellations now, where you have a whole group of satellites that all work together to do something, some job spread around the sky. They're called a constellation of satellites. And as they're spread out along their orbital path, you don't see them as close together anymore. But yes, you can still see them. You can certainly see them across the sky. So you can go out and see those someplace where the sky is dark. And as SpaceX launches more of these, you'll be able to see that. Diane writes into us and she says she came to the planetarium at age 12 and still remembers that visit. She says it changed her life. She's 72 now. Thanks a lot. We certainly do appreciate that, Diane. Yeah, it's a really moving experience to come enjoy the planetarium. So if you haven't been to visit the planetarium lately, come check us out. You'll have a wonderful experience. Okay, so let's just finish off some other stuff here, folks, about what you can do to enjoy the evening sky. Still send us questions if you like. We'll be glad to take your questions for the last few minutes of the program here. I just wanted to remind you that local astronomy clubs around the Delaware Valley are now in their Star Party season, where they host public observing events for people to come to look through their telescopes to see what's available to be seen in the night sky. I just wanted to remind you that there are a number of these opportunities available for you almost anywhere you live. So the Delaware Valley Amateur Astronomers, a really excellent group, has their next star party at the Valley Forge National Historical Park Model Airplane Flying Field coming up on the 24th of this month, June 24th. The Delaware Valley Amateur Astronomers is hosting their next public star party. You can find more information about that at their website at dvaa.org. dvaa.org. You can learn more about their star party coming up then. The Bucksmont Astronomical Association is holding its next star. Oh, there isn't one scheduled for them, but you can check out their next program at the Bucksmont website, which is bmaa at bma2.org. bmaa at bma2.org. Next up is the Cherry Springs Star Party. Cherry Springs is this fabulous location up in north central Pennsylvania, right on the New York state border, one of the best dark sky sites on the east coast of the United States. Cherry Springs State Park is set up specifically as a dark sky observing location. It is a designated dark sky location, and the Cherry Springs Star Party comes up June 15th through 18th. So if you just search Cherry Springs Star Party, you can find out plenty of information about that on the web as well. If you have time to do it, I'd really recommend you stop in to check out what's available there. There will be plenty of telescopes. The sky is really dark, and you'll get a great view from there. The Rittenhouse Astronomical Society is hosting its next public event at Columbus Square, along with the Philly Moon Men. So this is a great opportunity right in the city to get a look at some objects through some telescopes right here. And if you're much further north from here, out in the Allentown region, the Lehigh Valley Amateur Astronomical Society hosts its next star party on June 24th at their South Mountain Observatory. All of these groups are really excellent groups, experienced people with really good telescopes who can help you have a really wonderful experience enjoying the night sky. So I highly recommend that you give that a shot. If you need a star map, there is a website called skymaps.com. Skymaps.com creates printable star maps that you can use for wherever you are. If you're in the northern hemisphere, up here where we are, or if you're in the southern hemisphere, you can get a map from them, print it out, and use it with permission. It's free for use, and you can print as many of those as you like. But they're really good star maps, and you can make use of those. That way you can have something you can carry out into the field with you, and you don't have to take your smartphone, or you don't have to use your smartphone or take your laptop out. Of course, smartphones these days have all sorts of really wonderful sky apps that help you find your way around the night sky. Many of them are free and work really well. I have quite a few on my phone. I go for the free ones and they work really well. So, no objection there. You can find one that you might like to use for that. Of course, the star map that I like to use online here is a Stellarium Web Online, Stellarium Web Online, and you can find that at stellarium-web.org, and you'll be able to make use of that. So give that a shot if you'd like to give that a try, and that way you can learn your way around the sky. And of course, if you're interested in catching some satellites in the night sky, my recommendation always is International Space Station. Very easy to find information about that. If you go to NASA's website, nasa.gov, and search for Spot the Station. Spot the Station. You can even just do a direct search engine search for Spot the Station. It'll take you to NASA's website so that you can find out when International Space Station will be visible over you. So it's very easy to see. Just step outside, look in the right direction at the right time, and you'll be able to identify it as it flies over. If you take a look at what Venus looks like tonight in the evening sky, that's what International Space Station looks like as it's flying over. Nice and bright, very easy to see, no optical aid necessary. And that website was nasa.gov. Spot the Station is what you're searching for. If it's the star map one that you were very much interested in getting the URL for, that was stellarium-web.org. Stellarium-web.org. Okay, so give that a try. And the star map one was simply skymaps.com. Star maps won't get you there. Skymaps.com will. So give that a shot. Hopefully that'll do what you need it to do. So, all kinds of great things to see in the evening sky. Folks, next time around, we're going to start talking about how you can prepare yourself to view the solar eclipse that's coming up in October. Everybody across the country will be able to see some aspect of this, but I'm going to give you all the information you really need to know about when to look, where to look, what to expect to see, what kind of equipment you need to see it. And I even think that, even here in the Delaware Valley, we'll be able to see some of it as well. So we'll get you started on that. And Alan says that the Bucksmont Star Watch is on June 23rd at Temple University's Ambler campus. The Bucksmont Star Watch on June 23rd at Temple University's Ambler campus. Thank you, Alan. I greatly appreciate you searching that up for us. And if you take a look over in the comments, folks, you'll see that this is posted along with the URLs from some of the other websites I spoke of earlier. So I hope this has been fun and has been informative. We do this every month. Usually the first Thursday of the month happens to be the second Thursday this month, but we'll be on the first Thursday next month. You can join us next month. We'll have another topic that we'll be discussing, as I said, getting prepared for solar eclipses, but we'll also talk about planetary views available for you, as well as the constellations that'll be visible. By this time next month, we'll have some changes in planetary views. Oh, that reminds me. Don't let me forget this. Later this month, you really must do this. as I said earlier, just a moment, let me check one thing here because I need to be really certain about this. This will take me just a second to do, but hang with me if you will. Please just hold on, hold on. I want to make sure I get the dates right on this. It'll take me just a second. Just bear with me. Thank you, thank you, thank you. The cool thing to watch out for later this month is this: the moon. As it's rising late this month, let me get the date for you so I have the date right. Here we go. I'm almost ready. Okay, right, here we are. Okay. Here's what I really want you to be paying close attention to: the moon. I want you to be watching the moon, watching the western sky on June 20th, June 21st, and June 22nd. Just as the sky is getting dark, you want to see where the moon is starting on June 20th and follow the moon for the next several days: June 20th, June 21st, and June 22nd. Why? Because the moon on June 20th is going to be just down below the planet Venus. On the day of the summer solstice, June 21st, the moon, as a thin crescent, is going to be right next to Venus. And then the next night, it will have slid up just above Mars. So this is a great opportunity to cover a couple of things. Number one, you can watch the moon as it executes discrete portions of its orbit around the Earth. We see it in the evening here, and then the next evening there. Well, during the day, of course, it's been making its way along its orbital path around the Earth. Well, you can see the stations where it stops on each night: June 20th, June 21st, June 22nd. Then the next thing you can see, of course, is you can see the moon as it sits next to the planet Venus and near the planet Mars. Very cool. So if you were having difficulty identifying where Venus is, you can do it by catching it on the 21st of June when it's right next to Venus, and the very next night just above Mars. And even better, you can take your friends and family out to observe it too. And with a pair of binoculars, you'll have all the fun there is to have in observing both the moon and these planets as this is happening. So don't forget those dates: June 20th, June 21st, June 22nd. You're looking for the moon in the evening sky as it slides past Venus and Mars. Okay? That's your viewing assignment for the month, folks, along with everything else we talked about that you might want to take a look for. So enjoy the June evenings. Temperature's nice and warm. As soon as the smoke gets out of the way, you'll be able to view. Remember, what we talked about is good for several weeks, so don't feel like you have to do it tonight or tomorrow night. You can give yourself a few nights. And if you do this observing on a regular basis, the other thing is it becomes regular for you. You become so familiar with it, you remember it from night to night. And then you will have learned some of these constellations of the night sky really easily. Okay, that's it for our programming this evening, folks. We'll see you again next month on the first Thursday night of the month. This has been Night Skies at Home, a Franklin Institute presentation that helps you